Hi everybody, my name is Jocelyn Ross and I am going to be talking about mammalian origins and paper. So I hope you enjoy it. Let's start at the beginning. Okay, so we're going to be talking a little bit more about the radiation of placental and marsupial lineages. And I picked this topic because I thought it would just be super interesting to see the differences between the the marsupials and the placentals and why they diverged and when they diverged. And I just thought it would be interesting. So to start off first, we are going to talk about what a mammal is, how you find it in the fossil record, what the origins of the mammal are, kind of where we came from, a little bit more about what defines a mammal. And also we're going to talk about the three groups of mammals, but we're specifically going to be focusing on placental and marsupial mammals because that's what I was more interested in. And then when and where placental and marsupial mammals radiated and why it's so important to study about the mammalian kingdom because it just really is, and we'll talk about that. So first off, we're going to talk about time periods. So we're going to be focusing more on the Mesozoic era. As it says in the bullet point that the non-avian dinosaurs, they went extinct during the Cretaceous period. And so that's around this time period. But mammals originated earlier than that, as we will talk about later, but they radiated during this era. And so this extinction of the dinosaurs, it opened up the niches for the mammals to fill. And they beat out the reptiles to fill in all of these niches because they were just more adapted and better able to take on the climates that were new to the earth at this time. So if you will just remember the time periods around 250 million years ago to about 60 million years ago, that's the time periods that we're going to be talking about. So the Cretaceous, Jurassic, and Triassic. So we're going to start at the beginning, the origin of mammals. So I found that mammals originated around 190 to 200 million years ago. And this is during pretty much the Permian period. This is at the end of the Permian period, going into the Mesozoic era. And if you look over here, you can see that other tetrapods were taken to mean kind of reptiles. The mammals originated from reptiles. I mean, the reptiles that we have today are over here, but a reptile-like animal. And we're going to talk about therapsids mostly, and mammals, of course. So in this picture here, you see what helps us or helps scientists to know what a mammal is in the fossil record. They are set apart because you can see the mandible and the ear bone, what it says right up here, that they are separated. So if you look right here in the therapsid, that these bones are connected to the dentary or the mandible. But in the early mammal, you see that they're not. They're completely separated from the jawbone. They don't connect to the jawbone or the mandible, and they have become ear bones actually, which is kind of cool. And this picture doesn't show it very well, but there is an expanded brain vault. And a lot of scientists also use the dentition of mammals to tell if it's a marsupial, a monotreme, or a placental mammal. So they look at their molars, and I'm not completely certain about what they look for in molars, but it's so important that they understand the skull of a mammal to be able to tell if it's a mammal. And what you learned in high school is that mammals have mammary glands and hair, but that's really hard to find in the fossil record. Also, we're going to be talking about two groups, the Therian and the Prototherian groups, which is actually split into 3 subgroups. So Therian means that they give live birth, and Prototherian means that they don't. So if you can think about some mammals that lay eggs, that's a Prototherian, the monotremes, right? So Eutherians, that's when they have a fully developed placental. So that are the placental mammals, of course, and they give live birth. And Metatherians are talking about the marsupials. So marsupials do have a placental, but it is not as developed, and we will talk a little bit more about that later. So to sum that all up, we came from reptiles, and then the Therapsid, which is a mammal-like reptile-ish kind of animal, and then there became mammals, and they were first egg-laying. So monotreme styles of reptiles. So placentals, we're going to focus on placentals right now. So of course they have a placenta, which means that they use an umbilical cord to feed the fetus. And their fetus grows inside them, and they give live birth. So this means that their young are more developed at birth. And if you look at these features, they have more adult-like features. They have metanephric kidneys that work and that can use the food, that they can process food. They have lungs that work well and mobility, and usually their eyes can be open and their ears work just fine. And so they have more adult-like features than other mammals. Because monotremes, they have an egg, and they hatch out of the egg, and they're just not as developed. And also the marsupials. So because placentals are so more advanced at birth than the monotremes and the marsupials, it increases their chances for survival. So resisting stochastic events. So stochastic pretty much means unpredictable events like climate change or just things that can happen that they can't really evolve to. So it helps them to resist these events that happen. And this is what has probably made them the most abundant mammalia subclass out of them all. There are so many more placentals than there are marsupials and monotremes. So marsupials, they also have a placenta, but it is different. So the young have to go to the pouch where it attaches to the teat, but this acts like an umbilical cord. So they're the same because they have the use of an umbilical cord, which just feeds the fetus, right? But they're different because the young actually have to travel to the pouch, which places more stress on the young. And that is why they don't think there's many marsupials, because the stresses to grow up inside that pouch, they're just higher because they have to move. They're more out in the open, and it's just not as easy for them to overcome stochastic events. So in order to understand the diversification of marsupials and placentals, we have to first understand the continental drift. So everybody's heard of Pangaea, and Pangaea was a supercontinent, and it rifted apart into 2 supercontinents called Gondwana and Laurasia. And they say that this happened around 150 million years ago, and some other scientists might disagree with that, but we're going to go with about 150 million years ago, which fits into our timeline pretty well. So keep this picture in your mind, and we'll talk a little bit more about this. So Gondwana included South America, Africa, India, Australia, and Antarctica. Laurasia included North America, Europe, and Asia. So if we go back to that picture, you can see Africa, South America, Antarctica, Australia, and India. And then up here you have the North American continent and Asia, and you can just see those. So during this time of the rifting of the two supercontinents, the theory and groups diverged. So the placentals and the marsupials diverged around 166 million years ago. So you can see that the divergence happened on Gondwana, and they have found that there's no marsupials found in Laurasia, but there are marsupials that are found in Gondwana. So the placentals radiated into Laurasia, but the marsupials didn't. And that is quite interesting, that it's so important for these continents to have drifted apart at these times, because you can trace their origins. So to talk more about the radiation of mammals and when they diverged, we talked about the theory in the prototheria group, diverging from the Therapsid, or originating from the Therapsid around 190 to 200 million years ago. And that's around this time period that you can see right here. And we're gonna, these two mammals that are highlighted, the eomyi and the jurumyi, are super important. So at first, scientists thought that the eomyi was the closest relative to the marsupials, because you can see there's not very many more. They originated around 125 million years ago. So they thought that the divergence of the marsupial and placentals was around 130 years ago, because they had to give time for divergence of these two groups, because the eomyi is a placental. But then they found the fossil of jurumyi sinensis. I'm kind of slaughtering these names, but they lived around 160 million years ago. So that means that the time of divergence for the placentals and the marsupials moved up about 45 million years. And that is a huge difference. So now they diverged around this era, which is about 166 million years ago. And so we see that the divergence of mammals and the radiation of mammals really did happen during the Jurassic. And that is a lot earlier than they thought, especially since most dinosaurs, like all of the dinosaurs, died off in the Cretaceous. And so mammals were already starting to fill in the niches that were being left behind by the dinosaurs. And we're going to talk more about convergent evolution. Placental mammals and marsupials, they are so similar, as you can see in the graph or the picture at the right. Their niches are pretty much the same, and they have pretty much the same adaptation, same abilities. So how they tell it's a marsupial or a placental is through their skulls again and through their birth process. But convergent adaptations, they're so similar that it has to be that through their ecological niches, they just came together. And this is a way to see natural selection working on a group of animals. And it's really interesting because they don't really live next to each other. There are a couple of marsupials in South and North America, like opossums, but those are not close to anything that we have in mammals. So you can just see like the moles are pretty much the same. And you've heard of the Tasmanian wolf and the wolf that we have in the North American continent. And it's just so cool. And there's no homoplasies found. So we learned about homoplasies where a trait would be in the DNA would just pop up again, but that hasn't happened. It's just been completely convergent evolution that's created these mammals to look so similar, which is so cool. And I just really like this statement that evolution did not create something new, it reinvented it, which is just so interesting. In conclusion, I just want to go back over that mammals are defined, or you can tell it's a mammal by their skull, by their teeth, and that's how you find it in the fossil record. There's the 3 groups of mammals, and they have their different ways of giving birth and the ways of surviving, and the placentals have by far outpaced the other 2 groups because they have adapted a little bit better. And something that I didn't tell you, but marsupials and placentals, they make up 99% of all mammalian species. So that is really cool that they have radiated that much. And monotremes, which are the earliest mammals, what we probably think mammals came from, they originated from reptiles, they are only about 1%. And so you can see how mammals have diversified and filled in those niches and become very successful. Also, it's important to understand Gondwana and Laurasia in the process of mammal evolution and how radiation happened and why and where radiation happened between the Therian and the Prototherian groups and why that's important. And then just to sum it all up, why is it so important to understand this? Because we don't know much about mammalian evolution. There were a couple of scientists that were like, we need to study this, and that we would learn so much from it. But not very many people have studied it. There's not very many people have understood the differences between marsupial and placental evolution. They haven't really looked to see why those things happened. And if we knew that, then we would come to know mammalian evolution so much more and why things happen and why convergent evolution has happened. Also, it helps us to understand why evolution works at all, how it works, natural selection, and helps us to understand that more. And also understanding the importance of ecological niches. You just don't know how important they are until you see that convergent evolution, which is so much more interesting than I would have ever thought. And so I just really enjoyed learning about this, and I hope you have too. And that is it. These are my references that I used in the PowerPoint. So thank you for listening. And that will be it.